Hey everybody, let's talk about how electrical circuits are like ski resorts. So here's what the thing. When you're talking about electrical potential, it's helpful to talk about gravitational potential as a basic model for what we're talking about. So if you look at a ski lift, what a ski lift does is it adds gravitational potential to skiers. Then when they get to the top of the hill, they go down the hill, they lose gravitational potential, and that turns into motion. Well, for electrons, a battery adds gravitational potential, and then the circuit that it goes through is where that electrical potential, I might have said gravitational potential, turns into something else. In this case, it would turn into heat because this is what's called a short circuit. So this hill has nothing to get in the way. If you go straight down a hill when you're skiing, you go really fast, dangerously fast, and that would actually burn up the battery, turn it into so much heat. Now over here, this is like a ski resort with trees that you have to go around. This is kind of like the Plinko model that was in the other video. So as you go down the hill, you have to weave around the trees. You slow down a little bit. Not as many skiers can go by at a time. Or if this is a bulb or a resistor, not as many electrons can go through at a time. There's not as much current. So that's how a hill on a ski resort is like a circuit. They both have something that increases the potential, and then you decrease the potential on the other side. Now, what if you have a taller hill? Well, if you have a taller hill or more batteries, then you have more potential. With more potential, you're going to get going faster if that hill is steeper. And that means you're going to have more current if it's an electrical circuit with more electrical potential. Now, let's talk about current over here. Here we go. So current is Chromebooks are wonderful. Current is electrical potential difference divided by resistance. So basically hill height divided by how many trees there are. So that's I for electrical current, and delta V is potential difference, and R is resistance. That was the slope of that graph we got when we compared the effect of electrical potential on current. High voltage means high current. High resistance means low current. I is the number of coulombs per second. So Q divided by T. I is measured in amps. Amps are in coulombs per second. Here's an example of what this looks like. If we were wanting to figure out the resistance, the current in a circuit, we would say I equals V divided by R, or V equals IR, or possibly R equals V divided by I. So when you do that, you divide the voltage by the resistance, you get 2.1 amps. What that means is every second, 2.1 coulombs of electrons are passing any point in that circuit. Hope that example helps you. I'll see you in the next video.